And we're live. Welcome to our 8th free webinar in the 2019 Smart Building Series. And today we are talking about how can the cloud and machine learning improve the effectiveness of security monitoring stations. A little bit of housekeeping before we get started. First of all, we are today sponsored by Project Haystack, which is an open source project who are standardizing semantic data models for building technology. Would strongly recommend going and checking out their website, project-haystack.org, and you can get involved with what those guys are doing and helping to semantically tag data that's being produced by all these different building systems. And on to today. Today, I'm joined by Yves Neuhaus, CEO of NxGEN. Hi, Yves, how are you doing?
Thanks. I'm doing very good. Thanks, James.
Excellent.
And welcome to this webinar. It's great to be here.
Yeah. So just before we get started, as I said, what we're here to discuss is really about how recent developments in cloud computing, machine learning, and AI hardware is allowing security monitoring stations and control rooms to improve their effectiveness and reduce false alarm rates with video verification. Would be great if you guys want to subscribe to our content. You can do that. We have a YouTube channel also. It's available through iTunes. So go and leave us a rating there as well. All of that really helps us out. And of course, if you do have questions, this is like an interactive session, then please just type them in and I'll get the questions here. And we've left a bunch of time at the end to allow any questions for Yves or myself. So yeah, please do that. So yeah, Yves, over to you.
Okay, thanks. All right. First, before I start, let me quickly introduce NxGEN technology. Most of the people are not really aware of us. We're a Swiss-based startup company, about 2 years old now. We're just launching a cloud-based alarm and event management platform for monitoring stations. Platform integrates intrusion, fire, video, and IoT system, and is actually using deep learning for false alarm reduction. So part of the discussion in this presentation comes from the learnings we've made, based in Zurich and focused essentially on the European market. And quickly to myself, prior of having founded or co-founded NxGEN, I've worked for Honeywell on the MaxPro Cloud security solution, and I joined Honeywell through the acquisition of Extralis, which was marketing the AtPro and the Hightail product into the essentially monitoring station market. Okay, let's start and set the scene quickly for the presentation here. When we talk about cloud, there's often quite different meanings. Not everyone means the same. So there is different flavors of clouds. Essentially, there's 3 of them. So one is actually infrastructure as a service, which is a pay-as-you-go access to resources, computing resources, network resources. Essentially, it means moving your infrastructure to a managed data center. Takes away a bit of cost as it and reduces workload, as you don't have to manage the infrastructure, but quite often, to be honest, it's not very cost effective and doesn't really provide you much of the benefits of cloud as we understand it. The second part is platform as a service, which is essentially a cloud-based environment that allows you to build and deliver applications. So you get the infrastructure, but you also get a lot of tools and pre-built tools and services and applications from the cloud provider that allows you to greatly enhance the speed of your application development and also reduce your cost of development. So this is typically also the services that someone like AWS, Google Cloud, or Microsoft Azure would offer. And lastly, there is software as a service, which is a service provider delivering an application through the internet, or and you as a customer essentially just consume the application. So we, like NxGEN, for example, we use PaaS to provide the alarm and event monitoring handling as a software as a service. Now, same thing quickly for AI, and then we go into the subject. There is different parts of it, of AI. What is interesting for us essentially is machine learning and deep learning. I think it's important to understand the difference because they're similar, but not the same. So deep learning essentially is a subset of machine learning. And if I look at machine learning, pure machine learning is an algorithm that learns by understanding labeled data. So, for example, if I look at video, I look at the scene, I trained the algorithm by using for detecting vehicles and persons. Then I give him a lot of data from people and vehicles, and just tell them this is people and this vehicle, and they will start to learn what is a person or what is a vehicle. However, if I want them to use the same algorithm to detect birds, I have to retrain it. So I have to go back and tell him, give him a lot of birds so that the algorithm learns that this is a bird. On the other hand, deep learning is an algorithm that has numerous layers. So it's like it provides interpretation, or it is used to different interpretation of the different layers of the data that is fed into it. It's also because it's like it's a neural network. The advantage here is the algorithm actually, or the network actually learns itself about what these things is, using a feedback loop where it's saying, well, that is right or that is not. It's a bit like a child learning to understand what the visual things that it sees are. Machine learning has number of advantages. It uses very little, it needs less data, and it's used less computational power. Disadvantages, you need data that is structured. On the other side, deep learning is much more flexible, but needs much more data and a lot of more resources for training. So for example, at NxGEN, we actually use both approaches depending on the problem. So we use machine learning mainly for detecting change and tracking in video, whereas deep learning we use mainly for classification and interpretation, so to understand what the object is. So setting the scene, those two quickly definitions for AI and cloud as we see it. Now going over to the challenges. So what are the challenges that we see for service providers in the market? One of the things is actually customers are becoming more outcome focused. So customers are shifting away from buying a product towards outcome-based services. So it's the result that counts and less the feature. What that means is monitoring stations need to provide much more integrated solutions. So for example, as a residential customer, I'm looking much more for, I'm no longer looking for an intrusion service or intrusion alarm. I'm looking for a provider that can provide me security and comfort. That means when I come home, it should detect when I'm arriving. It should switch off and disarm the alarm system, switch on the lights and give me, and set the temperature and so on. So it's bringing together, it is an outcome, a result that customers are more asking. It started more on the residential side, but it's moving into business customers, and we need to monitoring stations need to be able to generate and create those type of services. We have a rapid rate of change. It's very quick technology change. It's difficult to keep the knowledge up to date. There's always people asking for additional new services, new types of features in there. Another area that a lot of the service providers actually struggle at the moment is talent. We have a historically low unemployment rate, and finding skilled employees is a challenge. In addition, through all the change, new skill sets are needed in IT, cybersecurity, AI, and even privacy expertise. And the other thing is, we actually do compete with other industries that pay in security that pay higher salaries for the same sort of skill sets. That puts pressure on the total cost of ownership. On one hand, you have increased HR costs because you need more staff, more specialized staff. It's more difficult to get. And we're staff in an intensive industry. We have to upgrade equipment, get new equipment in for new services, and it gets much more difficult now to improve the upgrade and site ratio. Another area, coming back a bit to outcome-focused services, is customizations. The customers are asking increasingly to have the services customized. They want to have specific workflows, change schedules. They want to have additional equipment or bring in some new equipment into it. And a monitoring station needs to accommodate this more and more. Also, customers are asking more and more to pay for services only when they need it, pay as you go. Regulations, our more regulations impacting the industry. The latest example that we had in Europe was GDPR, because of the growing concern of data privacy and security. These regulations actually increase the load in terms of change of the system, and it's very costly and actually very difficult often to implement this. False alarm rates. False alarm rates still one of the bane of our industry. They still have very high rates of 90% and plus. Yes, video and audio verification really helped to reduce this, so we can, for example, filter out animals nowadays. But one of the things we have is still we can't really detect the intent. So if there's a person, what's the intent of the person that analytics can't detect. And outdoor video is still battling with things like reflection, insects, and weather conditions. Faster reaction, you have to react faster and faster. The response process often is quite long, often due to incompatible systems. There's missing information. If you work with cross-border or cross-regions, when there are multiple languages, there's often language issues. This makes the reaction process quite long. Multiple information sources. There is a lot of issues when operators have to deal with different information sources because of new devices brought in the new data or a new management system. There is little interoperability. It is really challenging to effectively manage and integrate this information to provide a single view on an event with the current system. And there's a proliferation of devices. There's new type of technologies coming in. Equipment comes in. New equipment comes in at a very fast rate. So there's increased integration needed to provide services, and this requires more and more knowledge, despite the scarcity of talent out in the market. And not to forget is that cybersecurity in this context, which is already quite a difficult issue, is getting more and more difficult. Now, cloud and AI might not be able to, it's not able to address all those challenges, but it can address some of the challenges in there quite effectively and help to increase the effectiveness for the monitoring station to deal with these challenges. When starting with the cloud, a lot of a lot of people, when they think about cloud, would expect that addressing total cost of ownership is the biggest thing that you can do with cloud. Yes, by using cloud, I can reduce my TCO challenges by reducing infrastructure investment, because I no longer need to invest in infrastructure, have less staff costs, because that's now being taken care of the cloud provider. Also, my capex and my cash flow improves quite significantly because I'm moving away from a capex to opex model. So that helps as well, and also allows me, for example, to bring in maybe new services that I wasn't being able to bring in because I didn't have the cash up front to go for it. And by moving to a SaaS model, that aligns much better with the monitoring station service model, because PARs are essentially like a monthly payment. So you get a monthly service payment that links with the monthly usage-based billing that a cloud-based service provides. However, the biggest advantage that we actually see by using cloud is actually the faster deployment and the ability to bring new revenue streams online. I think the cloud allows us to go very quickly to an outcome-based focus, because we can react quicker to change, and we can implement customization fast and at a much lower cost. Essentially, talking about addressing outcomes and rapid rate of change is, with cloud, we have a browser and app-based system, and we are in constant contact with the user. So we can do customization and changes actually collaboratively. So instead of developing things offsite and then coming back, we can work with the customer and use variants. So we can, with the cloud-based system, you can actually provide different variants of different user groups to understand which one actually suits the customer better. And once you got the final version, you actually can deploy this version immediately, essentially after testing. The advantage is also, because the user was involved in, or the customer was involved in the development or part of the development, he actually knows what he gets, and it fits his needs. And we have seen that we can reduce time to deployment actually 2 weeks instead of like half year or yearly release cycle. One of the things that allows it to do this also is that the cloud services like Amazon or Azure actually give you building blocks to speed up the development of new features. So, for example, being asked to add augmented reality to the installation process, so that the technician can be supported directly when he installs some of the equipment. Previously, we would have needed to build the whole environment ourselves. Nowadays, you can go to a cloud service provider. For example, ours is AWS, and they have an AR-based service that is there. So we can use that service and just essentially customize that service for the need of our customers and then deploy it rapidly. So we can address rapid rate of change, and we can differentiate or customize the services more. And we can also provide more result-based services that the customer is looking for. Another area that helps where cloud really can provide advantages is the scalability, because it makes infrastructure planning and deployment much easier, as the cloud infrastructure and services essentially auto-scale. This actually allows actually to provide capacity to, for example, centralized functionality in the cloud that you might have previously out on the edge. For example, the NxGEN service actually centralizes alarm rules and scheduling for certain devices in the cloud and no longer in the device. There are some devices that have local alarm, disarm rules, which we have now shifted into the cloud. So we just do basic configuration out there and have all the rules in the cloud for this monitoring station to manage centrally. It improves the consistency and quality, so reducing cost, but also allows for automation of parts of it, because we have much better alarm information about the status and rules of the device now, because we are managing this centrally. Reducing the automation, using the automation that can reduce the operator workload and improve total cost of ownership. And as we have a browser-based system and we have a lot of the rules centralized, we can actually provide very easily a customer self-service application, because essentially the user just logs in with different application profiles. So you can and can then activate the activate service and so on. So using the central functionalities, the ability to have the processing power in the cloud that scales automatically really helps to reduce operator workload and improve, at the end of the day, the total cost of ownership. Talking about outcome focused as well, using cloud provides the ability to do cloud-to-cloud integration. So essentially what you do is you link two cloud applications together. This allows very quickly to integrate new services to address requests by customers, because there's a lot of other cloud applications in the market that can be used to provide other solutions. So for example, we have a customer that is providing security for parking spaces and parking and parking lots. The owner of those facilities has asked our customer if they could actually add in also parking management. Now, we could have gone out and tried to find a solution that in a traditional sense, but what we looked at was what other cloud solutions were around, and we found a video-based parking management solution. So we could use the same streams. We linked those two applications through cloud-to-cloud integration and provided and integrated that into our application framework. So it fully addresses the needs of the service providers' customers to have an integrated parking management and security solutions. And for our service provider, it basically generates new revenues, and this is being done within weeks. So it speeds up the provision of new services and the ability to provide new services with actually very little cost and development involved. Another area where cloud really can help is the regulation changes and cybersecurity. Cloud providers provide numerous services to address cybersecurity issues and regulations. And more importantly, they actually also provide a lot of the required compliance reporting. And by the way, many of these services are actually based on deep learning, so they're actually also using artificial intelligence. But that means this type of sophisticated capability can only be really made affordable by the economies of scale provided by the cloud, because the cloud providers also use those services. So a lot of the issues around cybersecurity, like checking vulnerabilities, updating, and so on, is really taken care of the cloud provider. So that relieves the monitoring station from a very, very difficult task and a big cost block. It also addresses the issue of lacking skills and talent in the market, because we can tap into the talent that the cloud providers have. Now, another reason to go cloud-based is also we actually believe that without the cloud, you cannot use artificial intelligence and security effectively. That might now sound a bit provocative, but especially with video, to use artificial intelligence with video, I think a distributed architecture really covering cloud to edge is really required. Because sending up video constantly into the cloud and having it processed in the cloud is not possible. There's bandwidth issues, there's cost issues, and so on. But now, using an architecture where a distributed architecture that covers cloud to edge with the algorithm extending end to end, that means from the edge device, either camera or NVR, going all up to the cloud, and have the data and storage processing done where needed. That's the way to go for artificial intelligence with the video in the future. At the moment, there's very cost-effective GPUs and VPUs now being available that are algorithms and with actually high accuracy out at the edge and detect and do the first processing and detection in the edge. In addition, the edge can then sort of defer back to the cloud for additional processing, a bit more power, where you can run more powerful deep learning algorithms. And we have to say, with the VPU, the new VPUs or GPUs that are out there, this new generation is very powerful. We actually have run 16 streams on an Atom process with 1 mirrored VPU to alarm on persons and vehicle outdoors, things that were previously not possible. So I think we will see more and more of those VPUs going into all those devices and really speeding up and the processing and bringing also higher accuracy. With this type of architecture, we actually relieve the pressure on bandwidth because we either send only metadata when the local processing is sure that this is just a person or a number plate or a face, and it only can send the metadata. The metadata means essentially just says, we have seen this number plate, this and this place, this and this time, and so on. So not the video information. Or we can go and just send selected information like extract vehicles or persons instead of the whole video frame up for further processing. Processing locally also addresses latency issues for local applications that need fast reaction. I mean, it doesn't really need to have the number plate sent to the sender to the cloud to decide to open the gate. That can be done locally. Or if you have, not only would be a waste of bandwidth, but it would introduce latency. I mean, customers would wait and you wouldn't have that fast reaction that we want. By linking back to the cloud, for additional processing also improves the accuracy and the quality of the neural network and maintains it. Because this linking back actually also works as a feedback loop for training and also for customization of the deployed neural network. So we can actually use this to customize for certain conditions in a specific site as well. But all the data goes up and improves the neural networks through the as input into the training for the neural network. And this is not only done, and that's the advantage of cloud here again, for one for one customer, but it's aggregated over all the different sites. So using the aggregation of the data actually helps to improve accuracy again, and is shared between the different customers. Being able to generate metadata with AI, this allows for forensic review and reporting. So this brings services in that you can then allow the search of the entire system based on keywords and then retrieve the alarm information from the local site. So you don't need to store everything up there, you just use the metadata to find where the data is. Overall, I think that this type of architecture that we see coming in more and more is greatly reducing, I think, false alarm rates with video quite significantly. There is other work being done for other systems, like doing on alarm data for example, intrusion alarm systems. Johnson Control, for example, has a system that goes in there. So I would expect that more and more this type of architecture and neural networks will extend to other type of data and helping then at the end of the day to reduce false alarm rates and help to react faster and reduce cost of ownership. By the architecture as such is actually quite flexible that we see, because you can actually add additional neural networks to it. So if you would add facial recognition to this mix, we could actually address one of the key nuisance alarm issues that we have. That we have a person in a space that essentially just has forgotten to arm or disarm the system and therefore created an alarm. Now this would pardon me. This would then allow it to build up an automated process, for example, where the intrusion system detects the person. We use facial recognition to understand if this person is allowed in this area, and we can disarm or suppress the alarm. We can even go further with automation, then adding an automated call to this person's mobile phone or a key holder to confirm that is allowed, without having the operator involved at all. So that once again reduces the operator load and cost that we face. So these are some of the examples that I had in terms of how cloud and artificial intelligence can make the monitoring stations work better and increase the effectiveness. There's many other developments and many other examples, but I think I stop here and hand sort of over for the Q&A.
Great, thank you very much, Yves. That was really interesting. And actually, I mean, there's some pretty technical subjects we're dealing with here, you know, cloud and artificial intelligence and all those kind of techniques. But we've got plenty of time to dig into it. So if anyone does have any questions for Yves, or indeed for myself and the work that we do at Memoori, then please ask them now. I mean, Yves, I mean, there's obviously like a lot to unpack there. And I mean, I've written down some notes about what sort of things that stood out for me. I mean, talking obviously about false alarms, I thought that was interesting. And clearly that is something that is, as you said, is sort of like a bane of the of the physical security industry, and they're still quite high, and there are things that are still difficult to you know, infer from video feeds. How are you seeing that change, like in the work that you're doing? How is deep learning and neural networks sort of helping that process of reducing that? Have you got any examples you can share with us?
Yeah, I mean, the moment our work is really focused on video, because I think the video verification is used quite often for trying to reduce false alarms by filtering to really verify what is in the picture or in the clip that comes with the alarm. One of the issues there, of course, is it takes a fair bit of time because the operator has to look into it and decide decide first what it is, and then decide if this is a nuisance or is this a false alarm, for example, because it's a large animal or so, or if it's a person. So I think machine learning will allow us, and the work we're actually doing shows this very clearly, is we can reduce a fair bit of this and automate, so the operator doesn't even see it, because with the classification that we get back, as long as if it says people or vehicle, and depending on what they're looking for, customers looking for, can be other things as well. As I said before, we can retrain it, we can retrain the networks and then go for whatever the customer is looking for. But that reduces then because the operator doesn't even see that if it's not within those the required tags. However, we're still security, so we need to make sure whatever actually is there, and we can't really say for sure what it is. We need to make sure that that is still being presented to the operator. So that's that where then the training comes into, and this feedback loop I was talking about. The better you use that feedback loop and the better you train, the more you can reduce that, and you don't need the second, let's say, you don't need to send it through the deep learning network, which can improve the accuracy. But there will be always things that the deep learning network doesn't know. I mean, we actually using two things. We have our own deep learning network, but then we also use Amazon recognition. So that's once again why cloud is so important, because Amazon recognition gives us much more object classes that we can use.
Okay. So they have their own service, their own deep learning trained network that you can leverage, right, as part of your for your service as well.
Correct. They have much more object classes than we have, because we quite narrow. On the other hand, their accuracy is less. In general, the services have more problems deeper in distance you go. If you go further, like 25, 30 meters on outdoor, it starts to become very sketchy sometimes. But yeah, we leverage that as well. We will never rely on it, but it helps us actually as training input, because we actually present that also for then for the labeling what came back from Amazon. So it's taking different resources together and build them into one solution to really increase the accuracy. So that should reduce the operator workload, because he only deals with people. He still needs to decide then, well, is that person really allowed to be there or not? And that's what I said before. I mean, interesting there, and I think that's where the future goes, is when you then bring in additional information sources that you run through optimized networks or algorithms that are focused on that data, for example, facial recognition. Because if that's an employee, and he is on premise, okay, then most likely you just forgot to design, and you can then you can automate that using an auto cloud. I mean, you can use Twilio then to send an automated voice call to them, and he just confirms it with the code that it's him, and then you automatically disarm the system. So that's where we go into intent, and I think that's where a lot of more work should be done to reduce for false alarm reduction, because that's where we still, I think, we still have a lot of it. Plus, then it's the usual, the spies and so on. They're still around, and that once again with object classification, you can actually filter out quite good.
Yeah, and again, I guess bringing those things together will help again reduce the decisions, I guess, that the operator has to make. Because ultimately, if we can reduce those, then or automate as much as possible, then that will improve total cost of ownership and reduce the amount of operating hours you need in the monitoring center.
Yeah. Plus, it is also, I mean, you can also start to probably a bit more in the future, start to do these services as on demand. So because you can actually download these networks, if you have them ready, you could provide the customer with the option to have this additional network focusing on facial recognition for access control, so for access control, and that gets then downloaded, so you actually start to generate some new revenue. Although I think that's still a bit in the future in there. I think the cloud-to-cloud integration is the essential part for monitoring stations if they want to add additional services for their customers, if they require it, because there's a massive amount of applications out there, and if you have the right, in our case, we work with our customers and talk and then try to find another provider, and then we manage the provider and integrate that application into our application. So with the parking management, that could also be, for example, a car management application, or you could link up with some facility management. I mean, possibilities are endless. I think that is one of apart from the microservices that the services that you can use from the cloud service providers, I think the cloud-to-cloud integration of application is one of the most interesting aspects of using cloud-based systems, cloud-based services. Yeah.
Yeah, I mean, we use AWS ourselves, and it's quite impressive the amount of different services they offer for different types of cloud processing. A question I wanted to ask about, you mentioned this feedback loop for training. Do you have a neural network for each client? Because then again, that what you were talking about, customization of clients is something that they're demanding more and more. Do you have to create one for each client because their needs are different, or can you have a general model that applies in all cases?
Well, we use a general model that we deploy. Well, first of all, we base ourselves on pre-trained networks, because there's no point in trying to do your own stuff, and there is enough out there. So we base ourselves on pre-trained network, and with the feedback loop, yes, we can then do that. Not really customer specific. We can probably go more like site specific by citing, but a site might have some specific challenges, and that's where we can adjust to the site, because we run our network on the NVR. We don't run it on the camera, so it runs over all the cameras that are connected to the NVR. So we can train that or we can adapt this to that specific site. I mean, one of the things is also running it means you have on the site means you have to run it on our own hardware, but it can also, when we run the exact same also in the cloud. So if a customer has legacy equipment, we actually connect the legacy equipment through the cloud to our platform, and then we actually run, let's say, the edge analytics in the cloud on the video stream that we get, on the alarm stream that we get from the edge. That is something we essentially do for like some legacy analytics that might send an event up there, then we can verify that event to make sure it's really an alarm or not. But yeah, so we can customize, but all the training data we use overall then to improve the overall network.
Okay, yeah, understood. You mentioned as well using AI or using, I guess, machine learning, whatever, to create metadata about that data as well. I thought that was an interesting concept. So, you know, maybe we could unpack that a little bit. I mean, essentially then, is that going to make it easier to find and sort and search information, sort it for compliance, that kind of thing? How are you applying that? How do you actually insert metadata into different bits of video?
Yeah, whenever it goes through our network, it does generate metadata, and we then take the metadata up into the cloud, and it's part of the data lake. So, as a customer, you have access to your data, and you can then run your own reports. For example, you can trying to understand which sites have what specific false alarm issues, because you can combine the metadata then also with other data that you have, customer data that you have that are in the data lake, and it helps you with your reporting. At the moment, we essentially generate metadata from video and from the other alarm data that we take in, for example, the intrusion alarms or the fire alarms that come in, or technical alarms from IoT devices. So you can then combine that, you can then do some time series, or you can then really run some data analytics on it if you really want to. That's very much at the beginning. At the moment, we just put them into the data lake, give you the ability to do reporting, and we provided a video search. So you've got the keywords, the extended keywords, not only vehicle and data, which we're focusing on at the moment, but also, for example, colors or other data. For example, if you get, for example, from recognition goes in there, then you can search these video alarm events based on those keywords. There's a bit what, for example, what Carter Maslin presented a while ago on Cameo. It's a similar concept. It's a similar. But we combine it then with more alarm information as well, so that you can also search for that alarm information.
Okay, yeah, makes sense. And I guess useful for compliance issues as well, like if you needed, specific data or, for evidence gathering, that kind of thing. I'm sure it's very useful.
I think it's most useful it's for forensic and reporting, and because you also have the audit logs. I mean, for compliance reporting, you need to have audit logs that are that you can't change. So because metadata you can essentially manipulate, but you can use the audit logs and feed it into the data lake and then do some reportings out of it. And you can then combine it with the compliance reports we get from Amazon about what is, for example, personal data and so on. So there's some, that's using cloud really gives you a lot of tools in that area that can help you then build very quickly things that if you want to do it yourself, I mean, you just don't have the resources, nor the scale, nor the money for doing it.
Right, of course, which is the beauty of the cloud. I wanted to just quickly to everyone listening, good opportunity now as we're coming towards the end to ask questions. Get them in now if you have any. One I was another thing I wrote down was about the distributed architecture and that being, you're seeing obviously a move towards that. I think it's fair to assume that bandwidth costs will go down over time. I mean, you think that we're going to move towards just more and more video in the cloud? Will it become, cheaper, more cost effective to process that there, or what do you envisage happening?
Yeah, I mean, you could say with 5G we got bandwidth everywhere, but I don't think actually it's too much also an issue of cost. I mean, yeah, cost, there is an element of cost, but I think the bigger issue in this context is the question, is the issue of availability. Because I mean, we're all living in the cities, we have fiber to the home and all that nice stuff, and megabytes, gigabytes of internet connections. But we shouldn't forget that a lot of times out in the countryside, what you get is maybe an ADSL connection. And that might be a pretty crappy connection, which means your bandwidth is actually quite limited that you have. You might not even pay too much for it, but you just can't pump enough through to get like 16 or 32 streams up. And especially in remote monitoring, a lot of those sites are actually out there. I mean, think of solar parks. I mean, they're in the middle of nowhere often. And to get the connectivity there is quite often a challenge. So I think the question of availability is much more is much a bigger issue than cost. I mean, cost is always an issue, but that I think it is a bigger issue, and therefore I've always said that you will need to have a distributed architecture, just not a camera and then stream everything up into the cloud. Also, the other thing is, I mean, frankly, a hard disk nowadays, a 2 terabyte hard disk nowadays, you get it for what, 50, 60 euros. Don't forget, cloud storage you pay as well. So there's a cost element. There's a cost element associated there as well. So using metadata to understand actually where the data is, I think is will not go away. I think we will for the foreseeable future we will still have lots of data out in the field. Yeah. There's compliance issue associated with that, of course, because you can only keep data for so long, which usually that's something you define in the device out there, which then deletes it. That's good. If you store it in the cloud, you need to make sure that every day that the data is so tagged that you can delete it as well. So that's another. Yeah, good point. I guess that could lead to issues, couldn't it, if you're uploading that kind of personal data. Yeah. So Yves, I guess my last question is, if people want more information about what you're doing with the company, or or sort of general questions about what we've discussed, where can they get hold of you? What's the best way to find out more information? Well, best way is I send an email or just call. Or go to the website, which we're actually currently redoing. So as we launched the platform now into the market, so that be probably more next month. But yeah, email, phone, that's the best thing to send, or LinkedIn as well. Okay. On LinkedIn.
Yep, and we can see that's up on the screen now, but anyone listening in, I'll check out the slides and you'll find the details there. Yeah, so just remains me to say thanks very much. I really appreciate your time, and I thought it was a very, very interesting chat about cloud and machine learning and how that's impacting security monitoring. Just remains me also to say thank you to our sponsor today, Project Haystack. Again, if you want to find out more about what they're doing, their open source project, very relevant to today's conversation about how they're standardizing semantic data models, please go and check out project-haystack.org. And as I said before, we recorded this, so if you want to share share it with your colleagues or anyone else, then it will be up on our website, memoori.com, probably later today. And as well, please subscribe. You'll find us on iTunes or YouTube. Just search for Memoori Research. So yeah, thanks very much, Yves. Really appreciate your time, and thanks everyone for listening.
Thank you very much for having me.
Bye for now.